Welcome to section 2.2. This section is very visual. They're wanting us to get a visual interpretation of functions, and so therefore there's a lot of pictures. And rather than me trying to draw those pictures and make them look nice, I thought it'd be good just to look at the MyMathLab homework together, and not every question obviously, but just some of the ones that you're going to run across. So here's the very first question, and you can see the graph off on the right hand side. And the question is, determine whether the graph is that of a function by using the vertical line test. So you know a function sends every x to unique y. And so what I want to show you is some things here. You can make this graph bigger by clicking on this plus. So if it's really small, you can make it look a lot bigger. And so now I can see about this graph. Now, here's an x value right here. It looks like each one of these are 2. So this is the x value of -4. Notice that it's being mapped to two different y's, one above and one below the x-axis. This is not a function. So what they're talking about with the vertical line test is if you were to draw a line, I don't think I can do that on my screen, but if I were to draw a line, would it intersect the graph in two places? And not just a line, a vertical line, a straight up and down line. And the answer is yes, in lots of places. But even if it happens once, it's not a function. So we're going to say no, it's not a function. It's only, since it's a yes, no, it's a final check right away. And I got a communication error, but I think that's my internet. So let me do that again. Yes, right? Nice work, right? And so there's always this question help up here. They can help you solve this problem. You can view a similar example. You could watch a video, but it could also take you right to the textbook where you would get the instructions. This Ask My Instructor is not so great. It would be better for you to just email me through Canvas saying, hey Jensen, I didn't understand question number 1 in the 2.2 homework, and I can respond. So notice it says here, type your answers in interval notation. So what's the domain look like? Well, the domain is all the x's, and these lines go on forever, right? So the domain of the function is from -infinity. Now, how are we going to get that infinity symbol? Right down here. So follow my cursor. I'll put it up here, and then I'll come down to this bottom, -infinity, comma, and it goes all the way up to -4. It actually includes the -4, so I'm going to use the closed bracket. Whoops, which I didn't need to hit the space for. But then it goes on, and I don't know if there's a union symbol at all that we could use. Yeah, here's one right here, union. And then we would go on the other side of 4, other side of the graph, which starts at 4. Trying to get the right symbol in there, 2, and then it goes all the way up to infinity. So let me go click that as that, and I'll go less, and we close that. So there's going to be some familiarity in the beginning. Let's see about the range. The range is definitely from -infinity, comma, infinity, and we close that. So using open brackets there like we would in the other answer. So I'm interested to see if it's going to accept that. So it doesn't like that. Doesn't think that my answers are correct. So I was worried about that, not knowing what symbols it wants. So let me replace this U with a comma. See if it likes that comma better. Whoops. I didn't know where I was in there. Comma. 4 to infinity. And it'd be interesting to see, if I keep missing this, what happened. But I do think that we're spanning all the y values. What are the domain and range of the function? Oh, that's the problem. I didn't read the full question, right? I do have the domain and range typed correctly. However, you're only going to answer that if it's a function. So the right answer is B. I apologize, it's not a function. So these are nice. We get that one for free. So sorry to waste your time there, but probably a good thing to have seen me do, right? Because that's what you'll learn is all the intricacies of the MyMathLab system. What are the intercepts of the function? Well, the graph's not a function. So we just keep choosing that. I don't know why. It makes sense to me why they're doing that. But if it's not a function, So the graph is symmetric with respect to the y-axis. Well, let's look at that. As we look at the y-axis, which is this big vertical one that I'm running my cursor up and down, is it mirrored around there? Absolutely. If I, how about with respect to the origin? If a piece is up here, is a similar piece down here? Yes. And how about with respect to the x-axis? Yeah, it does look like it's mirrored around the x-axis as well. Okay. And then select all that apply. The graph's not a function, right? And so let's check answer. Okay. So it says that that's not right. Does the only thing it wants me to mark is that it's not a function? Let's see. Yes. So even though there's symmetry, and that's really weird because there's never going to be x-axis symmetry if it's not if a function will never have x-axis symmetry. X-axis symmetry is a non-function. So I guess all they wanted us to do, even though it says select all that applies, is that it's not a function. So we're learning those idiosyncrasies together. So let's take a look at this one. Right? You see this guy now. Take a look at the ending points of this. It's got, I'm going to just make this really big, right? See how big we can make it. Oh, a little bit too big. I want to see the full picture and not have to scroll down. Is the graph a function? Well, you should recognize that guy. Do you see what that is? It's the cosine function, right, from our prerequisite. But is the graph a function? Yes. It's passing a vertical line test. No matter where I draw a line straight up and down, it'll pass. Okay, perfect. What's the domain? The domain, see these dots at the end? That means it stops there. So the domain's from minus pi to pi. So we do minus pi, comma, pi again. And I hope you're okay that I'm doing it here with you in the actual homework. I think it helps. And what's the range? Well, you know the range. The range from -1 to 1, right? Based upon our experience last time. And we'll check answer, right? And so the reason why they have this option as not a function every time is because they keep alternating what kind of picture they put there, right? So we continue. Don't know why I didn't automatically continue. The intercepts. Well, what does it look like the intercepts are? The intercepts are, sorry, didn't hit the right button. So parentheses, and it looks like a minus pi over 2. So we're going to get I'll get my minus out in front. So I clicked off of that. Now I clicked my right arrow over and up top. I'm going to get the pi over 2. And see if I can get that. And then comma 0. Let's see what happened there. I don't know why I'm not in the box there. Comma 0. And then we also have the intercept of 0, 1, just moving from left to right. And then we also have the intercept of, and then again we'll use the fraction. And I don't know, yeah, it just makes them automatically bigger. That's good. Pi over 2, whoops, it didn't click my down arrow. Pi over 2, comma 0. So it's going to take a little bit to enter those in. Check that answer. One or more incorrect. And here's the problem. I don't think I separated them. So use a comma to separate those. So that's really important. So let me get in here. And I think the only reason why I missed it was because I didn't have commas in there. So let's see where my cursor is. Now it's in the right place. It's between that and get some commas in there. I don't think it got that last comma that I put in there. Now let's check that with the commas in there. Nice work. So that's important. So I'm trying to stress the things that are important because the computer's grading this. And we'll continue to the next question. And then, is the graph symmetrical? Yes, it's symmetrical. Is it symmetrical with respect to the origin? I don't know. So if we look at this part, is it down? So let's take a look at something. So this is pi over 4, and well, we know it's root 2 over 2. So this is pi over 4 root 2 over 2, negative pi over 4 negative root 2 over 2. It would have had to be right down here, and it's not. So it's not symmetric with respect to the origin. Obviously, it's symmetric with respect to the y-axis. And we're going to check that. And we're going to get good job. And they're going to move us on to the next question. And so you can see that you're going to do this a few more times, right, as you go through this homework. But this is why I didn't want to belabor what you were looking at. So how about this guy right here? Is this graph a function? Does it pass a vertical line test? And the answer is yeah, it passes a vertical line test. At no point in there are there duplicate y's. And so we final check that. Oh, I answered no, it's a function. Sorry. I clicked the wrong thing, right? I said, yes, it's a function. It passes the vertical line test. And probably it's why I was saying, hey, at no point in there. So let me show you what you do if you need to redo a question. I think you have to finish this one. But you could just type something in here like, just choose the graph as not a function. Check answer. Because it's going to give you partial credit for that. And then check answer. And check answer. And then it's going to give you what the right thing is. I'm going to click C in here again. Check answer. What I want to show you is what happens when you've missed everything. There may be a better way to do this than this. And what I'm doing here is just missing every problem quickly in order to show you what you're able to do. So you're gonna have missed all these parts, right? And if I really had a question, I could go to the question help. Notice it says similar question now. So when I click that, I get what they feel is a similar question, but it looks different, right? It's this parabola looking thing. So I'm a little bit disappointed that I can't do that other thing. But that's how you can get it. If you've missed a question, that's how you can get one that's very similar. So you can see that there's a bank of pictures that they're drawing upon. So let me click similar question to this one, because that looks more like what we had. Sorry, it must have advanced me a question, and then I click similar question. So this is what we have, a very similar question. Is it a function? Yes, it's a function. And so now I can start getting this question right. What's its domain? Well, the domain is where it goes to and from. And because of those arrows, the domain is all reals, or from negative infinity to infinity. Oops. I need to get a comma in there. I don't think one registered. At least I didn't see it. And the range of values isn't everything. It goes as low as we want because those arrows go down. Sorry, I'm doing the same thing. I'm hitting caps lock every time. Negative infinity. All the way up to what value? Well, we get as high as 6. Do you see that happening? And we actually achieved the 6, so we'll put a bracket in there. And we'll check our answer. So we're really hoping that it's not a function, because then it's fast. You just click and graph's not a function every time. What are the intercepts? So where is it crossing? Let's start from left to right. I'm seeing a crossing, and each one of those looks like they're 3. So I think I'm seeing a crossing at -6, 0. See that there? I'm claiming that I think this is -3, -6, -9, -12, -15. So that's where I'm getting the -6. I'm going to remember my comma. And then I'm seeing another one at 0. And it looks like those are a height of 3 as well. So 0, 6. And then I'm seeing another one. So remember my comma in between at 6, 0. And those look like the 3 that I have. And so it's going to take a little bit of time. to put them in. So is it symmetric with respect to the y-axis? It does look that way. It looks like this piece right here is completely mirrored over the y-axis. Certainly it doesn't have x-axis symmetry because we don't have anything down here. And it's not symmetric with respect to the origin because this piece right here isn't down here. And so I'll check that. I think that's the only one. And it's moving me on to the next question. So that's what the homework's going to feel like from these visual things. So you have about 6 of those. And then I wanted to do the end question with you too in this. I'll probably post another video for the intermediate ones because you'll need to see the algebra there. So this is a good one to look at. They're asking for f plus g of 4. And I'll show you how this is to be done. So they want to make sure you know how to read graphs. So I'm going to make this as big as I can and still keep it in the picture. So look what they're asking for, f plus g of 4. Well, where's f? F is this red line, and g is this blue curve. You can see that they're labeled here and here. So let's find 4. Here's 4. So 4, negative 2. So both f and g are both negative 2. So remember what f plus g of 4 is. It's f of 4 plus g of 4. Well, what's f of 4? F of 4 is negative 2. G of 4 also is negative 2. So what's negative 2 plus negative 2? Well, it's negative 4. You're just adding those two results. It's kind of unfortunate they run on top of each other. Here they won't be. F of 6, f plus g of 6. So I'm adding a negative 6 and a negative 4. Remember what f of 6 is. It's the y value. So f of 6 is actually negative 4. G of 6 is negative 6. Together is negative 10. And you're plugging those in. And that's what this is going to feel like. And they're going to have you go through, a subtraction too. We'll do one more. And they might have a multiplication in there. How about 8? I'm going to take f of 8. Now f of 8, make sure you got the right one because it's subtraction. That's first. Negative 6. G of 8 is negative 2. Negative 6 minus a negative 2 is negative 4, right? Negative 6 minus a negative 2 is negative 6 plus 2. And so we check that and it says nice work. So we're doing our work on the side. And you can see that now they switch those positions for you to see that it's going to be different in there. Here we're going to do G of 8 first, which is negative 2, minus f of 8, which is negative 6. Negative 2 minus a negative 6 is negative 2 plus 6 for positive 4. And it's just going to say fantastic. And now we multiply. I think that might be the last one, so we can look at that. F of 4 and g of 4, both the same thing. Both are negative 2. Negative 2 times negative 2 is also positive 4. And we plug that in. And now we're going to divide. F of 6, well, what's f of 6? F of 6 is negative 4. G of 6 is negative 6. So that's a negative 4 over a negative 6. Well, they're not going to like that. They want us to simplify our answer. A negative over a negative is a positive. 4/6 is 2/3. And you can do that work on the side. But that's what that last one's going to look like as you go through and do that. And again, what do they want? They want a visual interpretation of what's going on, that you really understand what it means for a function value to be a specific number. It's a point on the graph. And we should be able to work back and forth from those. So I'll end this video and probably make another one for the intermediate stuff that's there. Thanks for watching.